Hello, Fargo Moorhead Robotics team. So I thought I'd go over a little bit about the Fargo code that we got up and running on the robot last week. Um, similar to last year, we had this configuration file that had constants for various configuration items. So if you look at my PID video, slew rate control video, I talk about these two settings. Some of these still may need to go away. The other thing I try to do is look at the various motors that we might use and set current limits. Since we've possibly let out the magic smoke on a few of the Neo 550s, I think it's very important that we try to stick to using current limits on all motors. So the Neo 550 really shouldn't be pushing much more than 20 amps. That's probably pushing it as long as we're limiting it to 20 amps for 2.5 minute duration competitions. That's probably fine. If we're like last year, if we're sitting there climbing for 30 minutes at a time, that probably isn't enough. Went through the bag motors and some of the other motors. Oh, I think I've got this one wrong. I will fix that right now. So then for the Fargo elevator, I added some parameters like a rotation deadband. So the Xbox joysticks have a little bit of drift. So if the controller is centered, it should read a value of 0, 0. But it sometimes drifts a little bit. So you might read a 0.1, 0.05 as it's kind of drifting around there. So what the deadband does is it just says, hey, if the value is not greater than 0.2 for the rotation or the extend, just ignore it. Then we have this rotation scale of 0.1, and I'll talk about that a little bit later. With the gripper, really we have this deadband. This closed set point is not used anymore. Just get rid of that actually. And then down here I have some of the parameters for autonomous. That I was messing with the other last couple of weeks, so we won't worry about that. Okay, so then the way the Fargo robot and the Moorhead robot currently are both organized, very, very similar. So we create this drive system, and you might need to double check this, but you give it the left two motors and the right two motors as parameters. For the Fargo robot, the gripper system has two motors, so we give it the left motor and the right motor. For the elevator, we have a rotate motor and an extend motor, so we give it those two CAN IDs. And then this LED subsystem was for Rory. We want to implement it. Yeah, we'll talk about that later. So then we define two joystick controllers, two Xbox controllers. That's how we had it last year. And I think this is something that you guys are going to have to experiment with to find out what feels natural, what is intuitive as you're driving the robot in the next few weeks. So what I ended up doing is for the second robot controller, I map the A, B, and the X button, which actually it should be the Y button now that I look at my Xbox controller here. And so the idea here is with the elevator, you could hit the A button and that would just automatically move the arm to the low position in order to drop a cone or a square, a cube. You could hit the B button to move the arm to the mid position, and you could hit the Y button to move to the high position. And maybe we map like the X button to flip back around or something like that. So we'll talk about that in a little bit later here. Then controller 1, the left Y and X control the chassis movement, and that's the same way that we did it last year, but once again, feel free to change this if this doesn't feel natural. This needs some work. The elevator is then mapped to the right controller, so the Y, the up-down, moves the arms up and down, and then the left-right moves the arms in and out. And then the gripper is on the second Xbox controller, and here I just mapped the X axes on both the left and the Y right. So basically, if you push them inwards towards each other, the two motors would pull the gripper, push the gripper into the middle, and then you just differentially move them left or right to slide that gripper system back and forth. You push them opposite to open the gripper. Once again, you guys will have to experiment with that. But I wanted to really focus on the elevator system today. So the elevator system is what we, if you looked at the video that Joe posted, we did try to get a PID controller to hold, or at least a PI controller to hold the robot arm. It definitely needs some work. But what we do is we come in here and we're using a brushless motor for the arm and a brushed motor for the extension. And so we have to have a CAN Spark controller for the brushless motor and a Talon SRX for the DC motor. We then reset both to factory defaults, which this should be there. And then we set the current limit for the Neo and the current limit for the bag motor, which I think is right. Joe will have to confirm if that's the right motors. Then we get the encoder for the rotating arm, and we set the position to 0. So here we always want to make sure that when we start a match that the arms are in a known set position, and that position is going to be 0. Okay, then we have a periodic function here, which is running the PID loop. So this periodic function is going to get the current position of that motor. It's going to calculate this PID controller. And so when we create the PID controller, we give it the KP, the KI, and the KD gains. And once again, watch my other video that explains a PID controller in a little bit more detail. So then all we're saying is you know, here's the position, calculate the PID controller. This really shouldn't be error. This is the new output, right? So this is going to drive the motor to some position. And then we're going to publish on the dashboard the current arm encoder positions, and let's call this the, so this isn't actually the error, this is the arm motor drive, right? That's really what it is. Okay, then we have this control. So let's go back to the robot here. So what we've done is we've mapped this run command. So what we're saying is that when the robot is in teleop mode, what we want you to do is just simply call this, call the control function of the elevator subsystem and pass it the value of the right y-axis and the right x-axis on the first Xbox controller. So this guy's going to come in, and now we're going to do our deadband detection. So if the absolute value of rotation, because that can go from -1 to +1, so if it's greater than our deadband, which right now in the config file we have it set to 0.2, so if that is greater than 0.2, well then what we're going to do is we're going to take this rotation scale. So in other words, if we say, I want you to rotate the arm to position X, when you push the control up, we're going to take that rotation value, let's say it's 1, we're going to multiply it by this rotation scale, which is 0.1, and we're going to add that to the desired position. So what that means is that this function gets called once every 50 times a second, so once every 20 milliseconds. So every 20 milliseconds, we're going to take the current rotation value of the Xbox controller, multiply it by 0.1, and add it to the desired arm position. So instead of moving the motor, you're now moving the set point for where you want the arm to stay. And then periodically, it's going to go ahead and call this guy to run the PID controller and set the motor to the correct position. And then we have the same thing with the deadband of the extension and retraction. We have a deadband, and then we're just going to say, hey, run the motor at 10% of its maximum speed and just drive the motor directly. So this doesn't have a PID controller. We might have to add that in the future. But on last week when we ran it, that motor spins extremely fast, and so we slowed it down. So that's what this 0.1 is. And then going back to our buttons here, right? So we had A, B, and Y. So we can, if you hit the B button, for example, when B button becomes true, we're going to run the move arm to mid elevator command. Well, what that command does is it sets the desired arm position to -8. So when the arm is sitting on the ground, rotations up from that position are in the negative direction. We could probably invert it, maybe. Anyways, so we want to drive the motor to the negative 0.8 or the negative 8 position, and we're just going to print a string that says we're going to mid. And so we need to change that to low, mid, and high. And so now if you don't touch the Xbox controller, this closed loop controller is automatically going to move that arm to that correct position. And that's how the elevator works. So we can talk about it later if you want, but hopefully this kind of explains how we can use PID controllers.